This next lesson is working with rational exponents. In the previous lesson, we were working with integer exponents. Now we're working with exponents that are fractions or possibly decimals. In order to understand fractional exponents, it is best to compare them to their counterparts, which are radicals. So what we're going to be looking at in this first investigation is understanding what the connection is between rational exponents and their counterparts in radical form. We're going to need to be able to use the calculator to do these calculations. So I'm just going to review that to make sure everybody's comfortable with these operations. So first of all, if I want to do 4 to the exponent of half, I would do 4, click my y to the x button for exponent, and it will depend on your calculator. Some calculators will allow you to put a fraction in here. Some calculators won't. Other calculators might require you to have brackets around this. So you're going to have to experiment with your calculator. For example, right now I'm going to put this in as a fraction and press equals, and I get the right answer, which is 2. So once again, you may need to put the half in brackets. Some calculators perhaps will give you an error when you put a fraction up here. You may have to do bracket and then 1 divided by 2. It all depends on the calculator. So that first answer is 2. Now, over on this side, to help with this investigation, I have filled in these numbers here, but note that I've put a 2 and a 1. These are both understood. If you think about what a square root means, it's a number that multiplies by itself to give you that particular number back. So that's the simplest form of a root that you can have. And so the default is when we put a root symbol, that's actually a 2, and we call it a square root. And as we've mentioned before, when we have exponents, when we have a 1, we don't need to write that. So here, this 4 is understood 1. But I wanted you to be able to be looking for the pattern between these numbers here and the numbers in the fractional exponents. So let's do a couple of roots just to make sure everybody's okay with this. Most people are familiar with doing a square root. So the square root of 4 is equal to 2. Now there is a button for doing other kinds of roots. For now, I'm going to show you that we could do a square root similar to what I've depicted here using this function, which has an x in front of it, which means you can put any root that you want. To do that, I need to put the number first. So let's put a 2 in, and we'll do a square root this time. And I'll do shift in that function, and notice it puts a 2 up here. Now I'm going to put a 4 in, and I'm going to put an exponent 1, even though, again, it's understood I don't need to do that. So here's that first way I depicted this question. And if we put equals in, again, we get 2. So we know that the answer here is 2. So similarly, if you want to do a third root, for example, you would put a 3 in, press the second button and the root sign above the y to the x, and put some value in. So we could do the third root of 27 and press equals. And of course, there will be roots where these will not be whole numbers or integers, but they will be decimal values. So what you'll need to do is go through and calculate the answers to each of these, and calculate the answers to each of these, and then consider what you notice about the answers to the problems in the rows, what pattern you see that relates the two expressions in the rows to each other, so these expressions here, and then express these in the opposite, in the other form. So take an exponential and express it as a root or a radical, and take a radical and express it as an exponential function. Now, if we go through and work through each of these, the third root of 64, when you put that in your calculator, you will get 4. And I'll illustrate a couple of these again. 64 to the exponent of 1/3 is equal to 4. Coming to the other side, the third root of 64, the third root of 64 is 4. If you do 8 to the 2/3, what you will end up getting is 4. And then if you do the cube root of 8 squared, which would be the cube root of 64, which sounds familiar to this question up here, you will get 4. 16 to the exponent of 1/4 is 2. And then the fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. Now, if we do 25 to the negative 1/2, that's a more difficult question, so I'm going to punch that in. 25 to the exponent, and I'm going to put a bracket since there's a minus there. I may not need to. And again, you can work with your calculator to decide. So to the minus 1/2. And this gives me an answer of 1/5. One thing you may find with some of these is, depending on your calculator again, there may be a few errors that come up where you'll have to find out, either look up online or figure out what's different about your calculator. You may have to do a couple of calculations a little bit different, but for the most part, these should work out fine for everybody. So we have here the square root of 25 to the exponent negative 1. Square root of 25. And I want to put that to an exponent, so I'm going to put a bracket out around all of this. And now to the exponent of minus 1. And once again, I get 1/5. Finally, 2 to the exponent 3 to the exponent 1/2. Now think of our rules. We could multiply those exponents. That would be the same as 2 to the 3/2. 2 to the exponent 3. And then that to the exponent of 1/2. In this case, we get what's going to be a decimal answer. Notice this has reduced it to a radical in simplest forms. And so the decimal here is 2.83 rounded. And hopefully at this point you're seeing a pattern in all of this. Now we're going to do the square root of 2 to the exponent 3. And once again, we get 2.83. So hopefully what you're seeing here is that these expressions are basically equivalent. So we can go from exponential form to radical form in order to represent these numbers. So we want to be able to go back and forth between them and have an awareness that this is true and how we connect them. So the answer here is that we noticed the rows are equal. what we've noticed is the answers in the rows are equal. Now, the pattern that relates these expressions to each other has to do with the fractional or rational exponent in terms of its numerator and its denominator, and then the root number and the exponent. So what you'll notice is that the denominator of the fractional exponent is the root of the radical, and the numerator of the exponent is the exponent of the number under the root sign. And you can see that here again. 3 is the root number and 1 is the exponent, although of course in this case we wouldn't have to write that. Here 3 is the root, 2 is the exponent on the number that's underneath the root sign. Of course the base here is the number underneath the root sign in each case. So that's what you want to become familiar with. We're going to practice that here, but let's write out that pattern. The base of the power is the number under the root sign the numerator of the rational exponent is the exponent. I'm going to put a short form there on the number. The denominator is the root. So putting that into practice, this expression here, now in this case, it's written 5/3 to the quarter. Let's write that using our exponent rules. We're going to multiply those, and let's write it as 3/4, 5 to the 3/4. So it's more in line with how we've been connecting these, not that we couldn't do it with that way as well. And so this would be equal to the 4th root, that's the number on the denominator, all over 5 to the exponent 3. And if we have the cube root of 54, remember there's a 1 understood here, so this is equal to 54 to the 1 is in the numerator and 3 is in the denominator, so it's 54 to the 1/3. Now what you want to do is just take that idea and practice going between the two forms in these example problems. So taking up these examples, this would be the square root of 3, and I'm not going to write the 2 because that's understood. This question here, the 3 in the denominator is the root, so this would be the cube root of 16 to the 1, and I don't need to write the 1. One thing to be aware of is that there is never a negative root. So let's make a note up here there are no negative roots. So the negative will always go with the exponent under the root sign. So in this case, this would be the 5th root of 12 to the negative 1. And since it's negative, we do need to write the 1. And this would be the 16th root of 25. Now, in the question, it says to evaluate each of these. So what you need to do is put these in your calculator and find the answer. (1.73), the cube root of 16, is 2.52 rounded. (12 to the negative 1/5). 12 to the exponent negative 1 over 5, 0.61. And the 16th root of 25 is equal to 1.22. Now this is rounded, but that means that 1.22 multiplied by itself 16 times should come out close to 25. And if we carried enough decimal places, then it would equal 25. Now in each of these, you're being asked to write these as roots again, and then to evaluate them. So this is the square root of 7 to the exponent 3. This would be the 5th root of 48 squared. The 6th root of 62 to the minus 9. And the 9th root of 13 to the 4th. First answer is 18.5. This answer is 4.7. The 6th root of 62 to the exponent 9. (488.2). 488.2. Ninth root of 13 to the exponent 4 is 3.12. And by the way, this question didn't specify how many decimal places, so I did vary here between 1 decimal place and 2. Unless specified, it really is up to you. In this row, there will be intentionally some errors that you will find. In this rule, there may be instances where you may get an error and you shouldn't. There is one question in here that will yield an error, and again, we'll be talking about that when we get down to here. First of all, minus 25, and this is where some calculators will, when you put this minus in front, will group that with the 25 automatically as though it's in brackets. So this is minus 25 to the exponent, 3 over 4, and that's minus 11.2. So if you get an error, you will need to do this a little bit differently. So if your calculator is grouping this minus with that 25, you will just have to do this a little bit different. You'll have to basically either take into account that minus or use the other minus button here. So you could go minus, and notice it puts 0 minus like it's a subtraction, 25 to the exponent 3 over 4. And this will also give you the right answer of minus 11.2. Or like I said, you can simply do 25 to the 3/4 and then know that there's a minus in front because there's no bracket around these. 85 to the exponent 0.46, 7.72, now this last question here, minus 13 to the exponent 3 over 4. In this case, you do get an error, and when we do the next line, we will talk about why that is. So in this case, there's an error. Finally, looking down here, if you go through and try these questions, minus 4 to the exponent of 1/2 gives you an error. Minus 4 to the exponent 1/3 and I forgot to put that in brackets. Minus 4 to the exponent of 1/3 gives me minus 1.59. Minus 4 to the exponent of 1/4 gives me an error. And finally, minus 4 to the 1/5 equals minus 1.32. Now, what you want to be thinking about is why do you get errors on these two questions and not on these? And the key is in the number in the denominator. So notice what's in common here is that these two numbers are even and these two numbers are odd. You cannot do an even root of a negative number. And remember that a root means that number multiplied by itself so many times. So let's work backwards and think about multiplying minus 4 by itself. Here we have a square root in this first one. The root of 4 is 2. Minus 2 multiplied by itself gives us 4. When you have two negatives multiplied together, or when you multiply with the same sign, the answer is always positive. So it's impossible to multiply two things together and get a negative answer. In this next illustration with the fourth root, it's a little bit trickier because if I do the fourth root of 4, that's going to be a decimal answer. So let me illustrate this with the fourth root of 16, which is 2. So if I had negative 16 and did the fourth root, even though you might think in your mind it's negative 2. 2 times 2 times 2 times 2 is 16. The reality is that this is again an error because we can't get a negative answer by multiplying four numbers together. So the fourth root of 16 is 2, but if I take negative 2 and multiply it by itself 4 times, this pair and this pair, for example, both make positives. So what we have is positive 4 times positive 4. These negatives all pair up to end up leaving with positive, so we're going to get a positive 16. We won't get a negative answer here. So whenever you have an even root and a negative as a base inside of a bracket, you're going to get an error. As opposed to here, third roots are fine or fifth roots are fine because a pair a pair of negatives multiplied together give a positive. Multiplying by another negative now would give you negative. An example of that would be if I used negative 27 and I did the third root of that. I'm using negative 27 because unlike a decimal answer here, it's an answer that we're familiar with. 3 times 3 is 9 times 3 is 27. So the answer to this is negative 3. When we take negative 3 and multiply it by itself, I call this the odd man out. All the pairs are going to make positives, then you're going to have one left over that's going to end up making everything negative again. So we have positive 9 times negative 3. Now it's different sign negative, so that works out to negative 27. So with odd roots, we will get a proper answer, unlike even roots where we will get an error. So the remainder of this is taking some questions and working through them on your own. Go ahead and give these a try, and then I will go ahead and write the solutions to these, and you can come back and check them. In these questions, we're using our exponent laws as well. Here I'm adding the exponents, so I'm adding fractions. You can do that on your calculator, or you can get a common denominator and work it through that way. On your calculator, you can simply use the fraction button. So we're adding the exponents. And we get 1 1/15, or as an improper fraction, that's 16/15. In this question, it's fractions and decimals, but we can still work through them the way they are. 16 to 0.2 divided by 16 to the half. 0.2 minus 0.5, that would be negative 0.3. So we would have 16 to the negative 0.3 all over 16 to the 0.5. Subtracting these exponents, we have negative 0.3 minus negative 0.5, so that's 16 to the negative 0.8. Writing this with a positive exponent, that would be 1 over 16 to the 0.8. And putting that in my calculator, that equals 0.11. Looking here, we have minus 1, minus 3/4. So that's minus 1 3/4, or minus 7/4. 24 to the minus 7/4. And then as a positive exponent, that would be 1 over 24 to the 7/4. Putting that in my calculator, now I could put either of these expressions in. This time I'll put that expression in. 24 to the exponent minus 7/4. That's 0.004. Now you can go ahead and practice this skill.